Okay. I have switched on the recording. You can start once the recording is ready. Okay, you can continue, Miss Ayana.
Is my screen visible to you?
Yes.
Okay, let's begin the beam drafting for the BBS section. So first, the structural department will provide us with the beam column layout. We have two types of beam section. First one is the detailed drawing of the beams, like this P3 beam. So here they are providing all the reinforcement, stirrups, and all detailings are given. And another type of drawing is the typical section. Here you can see it is B1 200 by 300 section. Here the main bars, stirrups, and the other and the hooks are provided in the section. So our purpose or our function is to draft the BBS for beam. So for that, first I'm taking an example of this beam B3. So we have to first check for the length correction. For that, first you have to pick the X line, that is pick the X line vertical. So in this layout, you can see that here is the beam B3. So this X line is drawn at the corners of this column. So we can put the X lines here. And here is also a column C1. C1. Okay. Then now this beam B3 is moved. Moved here to coincide with this column edges. So now we can see that the edges of this column in this section is aligned with the column C1 from the beam column layout. So this drafting is actually correct. Suppose when this column is pulled out or moved somewhere here, we have to select this line and move it accordingly. Okay. Now uh, next, we have some more beams that is coinciding with this beam section. So here is a B1A beam, B1B and B22. There are three beams that is intersecting this beam. So now we have to draft the X line or put the X line for this beam section. So for that, take the vertical lines or X lines, and here is the beam B1A. So it will start from here and the beam section, here it is the ending. Here is B1B. So this X line you have to put here. And now the last beam is B22. So this beam will coincide here. So we have to first check for this. So the beam X lines is here, but you can see the beam is, this is the beam section. So the beam section is not drawn. So we have to select this beam and you have to move this accordingly. So now you can check the dimension. So the dimension is 200. So the beam section B1 A is 200 by 300. So it is corrected. Similarly, we have to correct all these beams. So actually this beam is of the same, is aligned with this X line. So it is already correct. Now the position of this beam is somewhere. So we have to move this beam according to this X line. So here it comes. So while checking the dimension, you can notice that it is 200. So this is basically the length correction for the beam. This is the first step we have to follow. So after that, you have to delete all these X lines. Okay. So as you all know, this is the reinforcement. So the layer of the reinforcement should be in SRC reinforce. So this top reinforcement is the top main bar and this is the bottom main bar. And for some structural conditions, we are providing the extra bars. So these are the rebar to be provided. And also in beams, you can see there are stirrups. So this is a line that is pointing to the stirrups. Okay, now we are going to check the layers of the beam. So I have already told you that this is SRC reinforced layer for the main bars. So you have to check all these rebars are in same layers. Okay. So all of these rebars are in SRC reinforced. Sometimes it may be SRC leader. So in aadspro software, it will not be scanned properly. So you have to make it SRC reinforced. Now, this is a leader, that is SRC leader. And here we can see that there are this 2 is pointing that there are two numbers of 16 bars are the main bars provided. So, one of the correction to check here is the tip of this leader should point to the reinforcement so that it will be scanned properly. Now, in case of dimensions, the dimensions should be in SRC dimension layer. And this also you have to note that while checking the properties, you can see this is in aligned dimension. So this dimension should be always in this aligned dimension. Sometimes it may be in rotated dimension. So we have to change it accordingly. Okay. For the next, I am coming to this drafting portion. So, you know, this is there should be a cover distance provided for the beams. For here it is 50 mm. Actually, it is the clear cover provided, but the actual cover is the clear cover. Clear cover here is, I told you 50. So it is 50 plus you have to add here the diameter of the bar is 16, so we have to take half of 16, that is 50 plus half of 16 is 8 plus you can also see here it is the stirrups are provided of 8 mm, so we can add that too. So the total cover to be provided is 66 mm. Okay, but here the cover is 50, only 50. So we have to correct this cover. For that, select this rebar and then move this to 50 plus 16 is 66. So I have already told you the total cover should be provided is 66 mm. Okay. It's also clearly visible that this rebar is bent and a development length is provided inside the columns. So you know that this development length is provided to ensure that bond between the column and beam so that the load can be safely transferred from the beam to the column or the stress can be easily transferred. So the length of this rebar, that means this development length is calculated using the equation that is taken from IS 456. You can see here LD is equal to 5 sigma S by 4 tau BD. So this phi is the nominal diameter of the bar provided. Here we have the bar 60 or 16 mm dia bar, and sigma S is the stress in the bar at the section, and tau BD is the design bond stress. So we are calculating this tau BD from the table 26.2.1.1, and here in this case we are using M30 concrete. So the design bond strength tau BD will be 1.5 Newton per mm square. So by solving, so here uh, the bar diameter is 16 mm. So solving this LD, we get is 16 sigma S is 0.87 Fy, where Fy is the yield stress of the grade of steel provided. Here the steel grade is 500. So by solving the equation, we get it as 725. So the LD should be provided as 725. For that, first you have to check this. It is 250. Okay. And this length is 475. But from the side of the column also, you have to provide a cover distance. Here it is 50. But in case of column beam junction, or the cover to be provided is equal to the clear cover 50 plus the half of diameter of this bar. That is half of 16 is 8. So 50 plus 8 is 58. So this cover distance should be 58. For that, you have to select this rebar and move this to 8. Okay. So now measure this cover distance. It is 58. So this cover is corrected. Now check for the, so the development length will start from the column, edge of the column and this beam column intersection. So here you can see that this is 242 and 475. So this one is 242. So uh, total, I have told you that the total LD is 725. So 725 minus 242 gives you 483. Okay. So the rest of this length will be, you can click on this point and stretch it to 483. Okay. So the total length will be 242 plus 483, that is 725. So also this development length is corrected. Now you have to go for next side. So in this side, similarly, we have to correct this cover. For that, so it's also 50. So select this rebar and move this to 8 mm. Now it is changed as 58. Now check for this. This is also 242 and the rest is 483. Okay. So this whole bar is corrected properly. Okay. Now this leader should point at this bar to indicate that there are two numbers of 16 mm bars. Similarly, we have to correct the bottom bars. For that, select this. First, you have to check for the dimension. Here, the dimension is 50. That is, clear cover is 50. So make it as 50 plus half of 16. That is 50 plus 8, 58 plus here the stirrups provided is 8. So also, this total cover will become 66. So for that, move this to 16. Now you can check this as 66. Also, the cover is corrected. So the development length should be provided as I have told you 725. So it will come out of this beam section. So select this and pull out here. So there is a cover. So minus that cover from this distance, that is 58. Also, you have to keep a proper distance from this top rebar and bottom rebar. So the distance between this top and bottom rebar will be equal to half of dia of top bar, that is 16 and a half is 8, and half of dia of 16, that is 8. Total is 16. So this distance will be equal to 8 plus 8 is 16. So this length is 226 only. So the total development length should be equal to 725. So 725 minus 226 gives you 499. Okay. So the balance length should be 499. Also, make sure.
Ayana, you can
Yes.
even round it off to 500. Need not keep a fancy number. Okay. You can round it off to 500.
Okay, Rindu. Okay. So let's actually it was 499, so we can round it as 500. So give it as 500. Okay. Also, you have to note that while drafting a line, this should be always in ortho mode. Otherwise, this will not connect properly. Okay. Now join all this line together. Similarly, here it comes as 226. Okay, 226. And the balance comes as 500. Always make sure that all these lines are joined together, or it's a polyline. So select this one and you have to change it to the layer SNC reinforce. Okay, so it's also corrected. Now also this leader should point, or the tip of this leader should point to this bar. Now there is an extra bar, that is there's one number of 16 extra bar. For that, the distance between this bottom bar and this extra bar is, here it is 34, but actually the distance should be half of the dia of this 16 bar and half of the dia of this extra bar, that is 8 plus 8 is 16. So we need it as 16 only. So 34 minus 16, that is 18. Select this and move to 18. Now you can see it, this distance is corrected. Okay. Select this bar and point it to the extra bar. Now we have to draft or make sure that this drafting is correct for the stirrups. So usually the stirrups are provided at a distance of 50 from this column section. So here it is already correct. Otherwise, we have to correct it accordingly. Okay. So you can see here it is hash 18200. That means 8 stirrups are provided at a spacing of 200 So this dimension, these all are pointing towards the stirrups. So it should be in SRC dimension. Now you have to turn on the cube property bar. So while selecting this dimension, here it's a property box appears. You can see here text override. So press a space bar and then enter. So this dimension marking will disappear automatically. This layer, that is SRC stirrup, should be moved to the center of this dimension mark to scan it properly. Okay, so these are the basic corrections. So and this is the SRC beam layer, and the layer is correct. So once again, uh, this main rebar should be in the layer SRC reinforce, and this leader that is pointing to this main bar should be in SRC leader, and the dimension should be always in aligned dimension, and the stirrups tests are always should be in SRC stirrup. So these are the basic correction for the P. Now there is another section we have to consider while drafting beams. That is, for example, this beam is only 5840 mm. So here we do not need to provide the lapping. So usually the slapping is done when the section of the beam is greater than 12 mm. That is, length of the beam is greater than 12 meter. You have to provide lapping. For that, I'll show you an example. Here you can see a beam B4, B5, B6, B7. This length of the beam is greater than 12 meters. Okay, 12 meters. So we have to provide the lapping. The lapping is provided so that the two bars should act as one, or we cannot provide the bar with more than 12 meter. For that purpose, we are providing lapping. So there are some zones where the lapping is provided. In case of beams, not always, but in some cases, the uh, compression zones of the beams is usually at the top portion, and the tension zone is at the bottom portion from the neutral axis. So in case of beams, uh, the lapping can be provided at the middle span for beams in compression, and also in bottom section you can provide the lapping near to the support, that is near to the column. It is not always like that. Sometimes there is more number of reinforcement provided for some structural conditions, so this reinforcement is provided to resist more tension. So where there is more tension, more reinforcement is required. In that case, you have to provide the lapping accordingly. Okay. Here the lapping is provided in the middle section of the span of beam. So checking this, you can see it as the length is 8 by 20. So it is not more than 12 meters. So the lapping is correct, and it is also provided at the middle section. So now I am showing you how to draw this lapping. Okay. Take a polyline, and you have to draft the development length and the rest length of the beam accordingly. Okay. So suppose you're supposed to provide the lapping here. So select this. At this point, we are providing the lapping. First, you have to select a line and draw a line towards the bottom, which is equal to the dia of the bars, that is 16. So this length should be 16 mm. Now, I have told you that this lapping length is 725. Towards the left corner, draw it as 725. Okay. Now select a circle. So circle should be drawn at a radius of 3 times the diameter of this main part. That is 3 times of 16. When multiplied by we get it as 48. So it is 48. Now select this rebar and you can shift it towards the end of the column. Now select the 16 mm bar and stretch it towards the intersection of the circle and the line. Okay. Now select a line and draw here. You can select the trim command and trim this line off and delete the circle and this line. So here it is how the lapping is drawn. Choose this line and join together and convert it to the layer SRC reinforce for proper scanning. Okay. And the distance between these two bars are 16 mm. Sorry. So the distance is 16. And now you have to measure this. It is 222. So the rest is 725 minus 725 minus 222 is 503. So pick a line. Pick a line and draw. It has 503. Now join all the lapping together. And this is in SRC reinforce layer. And also this tip is already at this bar. So we don't need to correct it further. So basically the lapping is provided like this. Is it clear for you? Do anyone have any doubts regarding this? Please respond.
Students, you may unmute yourself and ask your doubts because we'll have to do an assignment based on the BBS, BBS and all those topics taught to you will be given as assignments. So if you have any doubt regarding the same, start clearing the doubts now itself. Don't wait till the end. Uh, Ms. Ayana, is your portion for the day complete?
Yeah, I think the drafting portions are already completed. Can we proceed to scanning?
I think we can wind up here because it's
Yeah.
or you can or you can just demonstrate a scan for them.
Yeah.
a quick scan can be done. Okay. So today, what mainly was taught is that how to dimension, how the bars has to be drafted, what is the spacing you have to give, what is the offset or cover to be provided, how to draft, which type of lines to be used, and layering and all such things were covered today. And this is the same procedure you will have to follow while drafting your assignments. You'll get a sample drawing to know which all layers to be used and layer names. So you can use the layer names from that, and you will be given a project to work with. Okay, you will be given two files, one as a reference and other one for completing the assignment. And you will be expected to submit the assignment after your main exams. You will be given ample time for the same. You can clear your doubts before that. The final assignment should be submitted once the final submission date is given. Without submitting assignments, you won't be given certificates for the same. So this is mandatory. Try to get involved. If you're not able to understand anything, if you have any doubts or if you're not able to understand, feel free to reply either during the session or after the session in the group. Okay. So you can continue, Ms. Ayana.
Okay. This B3 beam we have already corrected. Now I'm going to scan this drawing. For that, you have to open the aadspro software and take the beam. First, you have to select the BBS scanning option. So click on this property box, and here, so the starting bar mark should be provided above 500 or something in order to avoid the confusion. There are, while scanning, you can see here, it's marked as 503, 501, etc. So the beam section is 200, 300. So when we put this bar marking as 200 or something, it will become confused. So it's better to keep the starting bar mark above 500. So here I am making it as 600. Now the Fy value is, I have already told you here, the grade of steel is used as 500. So it is 500. And from the drawing, we provided this cover as 66. So the bottom and the top covers are 66. Bottom cover is 66 and the top cover is also 66. And the clear cover provided is 50 mm. So now you can go for scanning. So close this property box and scan the drawing. Come to AutoCAD section. So it's clear to you that the here the bar mark is 601. Actually, in first case, it was like this, 2 # 16. Now there is marks are all given. So we can identify this bar, this rebar is scanned. And here you can see, here it is 2 lecture stirrups. So the stirrups marking are also here. All these three, that is top bar, bottom bar, and the extra bars are scanned, and the stirrups are also scanned. Now, again, go back to this aadspro, and you can see here, this is the scanning details. That is how this bar should be cut, where, and also we can see the weight details. Now, you have an export option. Okay, here is an export option. We can export it to AutoCAD, Simple, Excel, and Excel with picture. Now I am exporting it to AutoCAD. select AutoCAD, and now export it to this. So the scanning is completed. So from this table, you can clearly see that this 600 denotes the stirrups. So here the size of the stirrup is 8 mm and the bar number 30. And we have this shape code here. And so this is the shape code for the stirrup. Similarly, we have the top and bottom bar as 601 and 602. Sorry, 601 and 603. So this anchorage and or the development length is in the round figure. We actually provided it as 483. Now it is round to 485. All these lengths are round to the nearest 5 or 10 mm. And the 602 denotes the extra bars. So it's also scanned. This way we scan the rebar details from aadspro. So the first step was drafting and the final step was scanning. So actually it's clear for you. I hope it's clear for you. Does anyone have any doubts? Kindly respond.
I guess they will respond sooner or later, Ayana, because it's a new topic and they might be confused at time.
Yeah.
Okay. If you have any doubt, just feel free to contact. We are here to help you out. And I hope everyone has access to AutoCAD. If not, find a solution for the same before the submission dates and get your assignments completed. We'll try to do whatever possible from our side, but the rest is to you. So your interest in motivation is the only way to keep you going till the end of this training. Okay. And comparing to the traditional method of preparing bar bending schedule, this is the best and effective method. So try to catch up with the modern era of civil engineering. And I'll be posting the assignment for next beam BBS assignments in the group. There will be a sample file, a final PDF which you have to submit along with the assignment and just show the same. Just a minute. I suppose my screen is visible to you. Uh, is the screen visible, Ayana?
Yeah, it's visible.
Okay, when you submit your assignment for the bar bending schedules, the first page will be the slab layout with the names of the beams, and each page should be of A3 size. So when you zoom into the A3 size, it should be visible. And first page, the slab, general slab drawing with the beams denoted. The second one is the corrected beam drawings. After doing all the corrections and scanning, the scanned drawing must be included. So you'll have the bar marking here. Then after indicating the same, you will have to add the bar bending schedule. The table you export from aadspro. Exporting and how to form the table and all these will be explained in the next session. Okay. Then you will have to include the weight details. How to import and add the weight details and all these will be explained. So don't get worried. I'm just showing the pattern. You will have to submit the assignment. And I'm giving you a sample file for doing reference. And this is a sample file I'll be sharing in the group. Now here you can see and even have access to the layer names which you have to follow while drafting. This is to keep you in a standard procedure pattern so that it is easy for us to understand what you have tried to communicate through the drawings. Okay. So try to maintain the same layer names and use the same so that it will be easy for you to work out. Once you're thorough with the software, you can try changing the layer names and all this. Only try it once you are thorough with the software. Otherwise, you will have multiple errors which will be difficult for handling. Okay, so initially try to follow the same pattern you are using. Once you're thorough with it, you can go for the customization side. Okay, so you have reference. This is the unedited file. You'll have the edited file here. And when you submit your assignment, I want it in a pattern like this. So your assignment itself is, so I'm sharing your assignment right here. The file will be shared in group also. Okay, just a minute. Okay. Now your assignment, you have this lab, you have the beam sections which are not edited. You will have to edit the same. If you have any doubts regarding the sections, you will have to mention them with a screenshot of the part you have doubt. And for doing the same, you have an option snippet. In every uh, laptops, there's an option for taking snippet. You will have to just select this tool, snipping tool, and then go to new option, select the window. You can copy, paste in WhatsApp and send the same. Or you can use the screenshot options already available in most of the keyboards. So use this method to share your doubts, because once there is a diagram to say what is your doubt, it will be easy for us to explain to you what is need to be clarified. Okay, so you will have, this is your assignment question. What is to be done is clearly mentioned over here. You will have to give the corrected BBS drawings, the scan drawings. So when you submit your assignment, you will have to share this AutoCAD file along with the PDF format I have shown earlier. If you don't know how to plot into PDF and all, just let us know that know the same. So we'll take a portion regarding the same in the next session. So we'll help you to plot a drawing into PDF. If you don't know the same, just let us know in the group and we'll be organizing the same the next session. I suppose the portion of assignment is clear to you. If you have any doubts regarding today's session or even the assignments, just communicate with us and we are here to help you. Okay. Thank you, Ms. Ayana. It was indeed a good session. And thank you all for being present. I hope you will be consistent in your forthcoming sessions, because losing a session will not help you complete catch up later. Okay. Uh, and please don't hesitate to ask your doubts. Okay, let's meet next week, the same time.